Hey there, this is MathCamp321, and in this lesson I'm going to teach you how to find the area of parallelograms and triangles. Before we get started, let's review the formulas that are required to find these areas. The area of a parallelogram is given by the formula area equals base times height. So this is actually the same formula as for a rectangle. The other formula that we're going to be looking at is for the area of a triangle. And this formula is area equals 1/2 base times height. And you might remember this formula from maybe a study of geometry in middle school. So for the first couple of questions, the directions are find the area of the parallelogram, remembering one very important fact, and that is that the base is always going to be perpendicular to the height. So let's remember that combination, that the base and the height are always perpendicular. So in number 1, we're told that we have a parallelogram, and the formula for finding the area is going to be area equals base times height. So I'm going to start by writing that down, and I'm going to write it again with blanks, one blank for the base and another blank for the height. Now, as I look at this parallelogram, the base appears to be marked as 10. For that reason, I'm going to put 10 in for the base. Now, there's a segment which is dotted, which connects the top of the parallelogram to the bottom and is also perpendicular to the bottom. This dotted line here represents the height, and the height is given as 6. So I'm going to go ahead and put this into the formula. If I multiply these two numbers together, I end up getting 60. So the area of this parallelogram here is 60 square units, or just 60. They don't give us any specific units, so just saying 60 will be sufficient enough. Let's move to the second example. In example 3, we're given another parallelogram. So I'm going to start by writing down the formula for finding the area of a parallelogram. Area equals base times height. I've also gone ahead and put blanks in to represent each of those variables. Now, looking at this parallelogram, it's pretty clear that the base is going to be 8. So I'm going to go ahead and insert 8 into the formula. Now the height, which is the segment that connects the top to the bottom and is perpendicular to the bottom, this particular height here is not labeled. We don't have a numerical value for it. So let's see if we can figure out what that height is based on some of the other information. Now, one of the angles, the one particularly in the lower left corner, is marked as 135. Now you might remember that when we studied parallelograms, that all of the consecutive angles are supplementary, and consecutive means next to. So the angles next to the angle marked 135 are going to be 45, the supplements. So this is 45 here, and this is also 45 up here. Not that the one up on the top left really matters. Now I'm going to focus my attention on this triangle, and I'm going to call it ABC, just so we have a way of discussing it. Now, angle ABC is going to be a right angle, because it's next door to another angle, which is a right angle. And if this angle is 45 at angle C, and this is a right angle here, well, that forces this angle up here to also be 45. So what we have here is triangle ABC, which is a 45, 45, 90. And we're told that the hypotenuse is 3 root 2. Well, to go from the hypotenuse to one of the legs in a 45, 45, 90, you're going to divide by root 2. So we're going to start with 3 root 2. We're going to divide by root 2, in which case the root 2's are going to cancel, and we're left with just 3. So what we've just found is the length of the legs in the 45, 45, 90. So AB is 3, and BC is also 3. Well, the important thing that I just found is that the height of this parallelogram is 3. That perpendicular segment which connects the top to the bottom is 3. So I'm going to go ahead and insert that into the formula and multiply these two numbers together, getting me an overall area of 24 square units. Okay, great. Let's go on to the second slide. Okay, now we're on our second slide of finding areas of parallelograms and of triangles. And now the directions have changed. Now we're focusing on finding the area of the specific triangle given in the question. So I'm going to start by writing down the area formula for a triangle, which is A equals 1/2 base times height. And I'm going to go ahead and write this with a blank for base and a blank for height. Now, in looking at this diagram, it appears to me that the base is marked as 22. So I'm going to go ahead and insert 22 into the formula. Now the height is going to be the segment that's perpendicular to the base. And that happens to be this dotted line that's marked as 18. So the height of this triangle is 18. And I'm going to insert that into the formula as well. Multiplication is commutative, which means that the order in which I multiply doesn't matter. So I'm going to multiply the first two things together. 1/2 of 22 is 11, so I end up really getting 11 times 18. And I'm going to have to reach for my calculator to actually do this, and that's fine if you do too. The product of 11 and 18 happens to be 198. So the area of this triangle is 198. Our next example, we're supposed to find the area of this shaded triangle. And I'm going to label this triangle ABC just so we can communicate about it a little bit more easily. Now the area formula is going to be 1/2 base times height, and I'm going to write that down and also write it with blanks. Now again, focusing only on the gray triangle, the base of that gray triangle is 7. So I'm going to put a 7 right here. Now what's very, very interesting about this is that the segment that's perpendicular to the base happens to fall outside of the gray triangle. And sometimes that can happen. Sometimes the height can fall outside of the triangle. So if I were to drop an altitude from C straight down, we get the right angle that we want, but it happens to be outside of the initial gray triangle. And that's okay. So the height is outside and it's got a length of 10. So let's just make a note saying that the height is outside. And now we'll complete the problem. Again, multiplication is commutative, so the order in which I multiply does not matter. So I'm going to multiply the 7 and the 10 together, getting me 70, and then I'll do 1/2 of 70. And 1/2 of 70 is equal to 35. So the area of this shaded triangle is 35 square units. Great! Let's go on to the third slide. Okay, so now we're on slide number 3, and we're looking at number 9, in which we have to find the area of a triangle. And the first thing that I notice is that they're giving us an isosceles right triangle. And by the isosceles triangle theorem, I know that the base angles are going to be congruent. And I know that each of these angles is going to have a measure of 45. Now, if we're in the land of 45, 45, 90 right triangles, and I'm given the hypotenuse, I can find the leg by dividing by root 2. So I'm going to start with my 5, the hypotenuse, and I'm going to divide by root 2. I'm going to rationalize the denominator, r to the d, by multiplying by root 2 over root 2. And then I end up getting 5 root 2 on the top, and then 2 on the bottom. So it's not the most attractive answer, but this represents one of the legs of this right triangle. So this is going to be 5 root 2 over 2. And this is also going to be 5 root 2 over 2. Now the next thing I'm going to do is write down the formula for finding the area of a triangle. And that formula, once again, is going to be 1/2 base times height. Now I'm going to write this with blanks. Now we discussed on the prior slide that the base and the height must be perpendicular to each other. And I think there's a common misconception that the base always has to be at the very, very bottom. I'm going to call the base this side right here, which I'm going to shade brown. I'm going to call that the base. So now my question becomes, is there another segment that's perpendicular to it? Because that segment would be the height. And there is. And I'm going to make that green. I'm going to make this guy right here green, and that's going to be the height. So the base is 5 root 2 over 2, And the height is also 5 root 2 over 2. So I'm going to insert those values into the formula. And I'm sure a lot of you are cringing right now at the thought of all these fractions and having to multiply them together. But it's not going to be so bad. Let's focus on the denominator first, because that's easier and it's going to just make us feel better about the whole thing. 2 times 2 is 4, and then 4 times 2 is 8. So the denominator is done, and it really wasn't a big deal. Now, on the top, we've got 5 times 5, which is 25, and we've got root 2 times root 2, which is 2. So really, we have 50 over 8. Both of these values are even, so I can divide by 2 or reduce by 2 and say 25 over 4. So the area of this triangle is 25 over 4. And hopefully you didn't find the multiplication of those fractions too bad. Let's go to question number 11. If the area of a triangle is 64 units and the base is 16, find the height. So the obvious thing that's missing in question number 11 is a diagram. So I'm going to quickly draw a diagram. Now, they're telling us that the base of this triangle is 16, and they're telling us that the height, or actually we're supposed to find the height. So what I'm going to do is I'm going to drop an altitude from this vertex up here. I'll make it dotted, and I'll show that it's an altitude by making right angle marks. And I'm going to call that h to represent height. And now I'm going to go back to the formula. I always feel like the formula and the diagram are like the most essential things you can start off with, and it really helps guide the problem. So we know that area equals 1/2 base times height. Now it just so happens that in this problem, they tell you what the area is. The area of a triangle is 64. So I'm going to go ahead and put that in for the area. And this is going to be 1/2 the base. So let's stop here. The base is 16. So that was easy. And then the height, I'm just going to leave h, because that's what I'm trying to find. Now let's focus on this 1/2 of 16. What is 1/2 of the number 16? Well, as you may have guessed, it's 8. So we have 64 is equal to 8h. And if we divide both sides by 8, we're going to get that h is equal to 8. So we've just successfully found the height of this triangle by working backwards. Okay, great.